Okay, gentlemen, now we are at page 36 of your chapter 11 note. Okay, we are now at this question that do it 9. Okay, we are looking at this regular hexagon, okay, with angles x, y, and z. So in order to find the angle x, you need to use the formula to find the angles in the regular hexagon. So we have x degree, okay, is equals to 180 degree multiplied by 6 minus 2 over, okay, and we divide by the number of sides, which is 6 over here. Okay, so what the total is, okay, so that will be 120 degrees. Okay, now in order for you to find y, okay, you need to find this angle first, this angle and this angle. Okay, so in order to do that, okay, you need to use the fact that this triangle is an isosceles triangle. So therefore, angle FAE is equals to 180 degree minus 120 degree divided by 2. Okay, this will give you 30 degrees. Okay, then with that, y degrees is basically equals to 30 degrees due to alternate angles. Okay, we can use the alternate angles property because, okay, just this line and this line, they are parallel to each other. Okay, the moment you draw this line from B to E in the hexagon, it will be parallel to AF. Okay, now you have to see that the line EA, okay, forms a 90 degrees with AB. Okay, because A is entirely directly above E. Okay, so therefore, okay, since angle EAB equals to 90 degrees, okay, and therefore Z degrees equals to 180 degree minus 90 degree minus angle Y, which is 30 degree. Okay, and this will give you 60 degrees. Okay, this is sum of angles in triangle. Okay, now we are in example number 10. Okay, we want to find the value of n such that the angle sum of interior angles of an n-sided polygon is 1440 degrees. Okay, so the formula for the sum of interior angles in n-sided polygon, okay, it can refer to both regular or irregular with irregular sides. Okay, and this is equals to 180 degree times n minus 2, where n is the number of sides. So it is since sum of interior angles equals to 1440 degrees, 1440 degrees. Okay, 1440 degrees equals to 180 degrees times n minus 2. Okay, so now we want to find n. Therefore, you divide by 180 degrees on both sides. Okay, and you have n minus 2. Now we will calculate what is 144 divided by 180. We have 8 equals n minus 2. And then you plus 2 on both sides, you get n equals to 10. So I write n equals to 10 over here. Okay, and that's all. Alright. Okay, likewise for do it 10, okay, it's the same thing. Okay, sum of int angles is equals to 180 degrees times n minus 2. Okay, so now we have 2160 degree equals 180 degrees times n minus 2. Alright, then with that you do the same steps here. 2160 degree over 180 degree equals n minus 2. Okay, this is 12 equals n minus 2, n is equals to 14. Alright, so that that will be the number of sides for this polygon with sum of interior angle as 2160 degrees. Okay, now for example 11, we are looking at this angle x here, which is an exterior angle. Okay, but we also know that the sum of exterior angle of any n-sided polygon is 360 degrees. It is the same for all polygons. Okay, so as a result, okay, we want, in order to find x, we just need to sum up the angles 75 degrees plus 73 degrees plus 53 degrees plus 89 degrees plus x degree equals to 360 degrees. Okay, so to find x degree, we just simply need to move all these numbers onto the other side. Okay, so we just subtract the angles, all the angles here, and then bring this to the other side. What we get is simply 70 degrees. Okay, and that's all. Okay, or you can write x equals to 70. Okay, so likewise for do it 11, okay, we have the same thing. We have 65 degree plus 28 degree plus 84 degree plus 63 degree plus 46 degree plus x degree equals to 360 degree. Okay, so therefore x degree will just be equals to the subtraction of this entire value here. Okay, so the answer is 74 degrees. Okay, and that's about it. Okay, we now come to example 12. Okay, for if each exterior angle of a regular polygon is 20 degrees, find the number of sides of the polygon. So notice that we are looking at a regular polygon, and the one of the exterior angle of a regular polygon is given by 360 degrees divided by n. So this will be one of the exterior angle, and this will hence in this case equals to 20 degrees. Okay, therefore you want to find n, we just be simply you can just simply use in this case cross multiplication. So it's 360 degree over 20 degrees equals to 18. Alright, okay, then this is for part A. So for part B, okay, part B is just simple size of interior angle of regular hexagon. Okay, this will be equals to 180 degree times 6 minus 2 over 6 sided. Okay, so the answer is 120 degree. Okay, and that's all. Okay, so finally in do it 12, we are looking at a regular polygon again, with each exterior angle as 15 degree. We find the number of sides of the polygon. So again, we apply the formula 360 degree over the number of sides is equals to each exterior angle, which is 15 degrees. So n hence it will be equals to 24. So it is actually a 24 sided regular polygon. Okay, this is part A and this is part B. So for part B, we are asked to find the size of each of the regular, each of the interior angle of a regular octagon. So octagon, as the name suggests, octopus, it has 8 sides. Okay, 8 sides. Okay, so now again we want to use the formula again. We have 180 degree times 8 minus 2. Okay, over 8 sides. Okay, this will be the angle of the interior angle. So let's calculate this. So answer is just 135 degree. Okay, right, yep, and that's about it. Okay, so now let's finish up this summary quickly. The sum of interior angles of a triangle, right? Okay, so you can just quickly write this down. Okay, so triangle. Okay, then the next one, the exterior angle of a triangle is equal to the sum of its interior angles, and then that is the exterior angle of a triangle. Okay, then next one is the quadrilateral. Okay, just take note of the spelling. Alright, okay, then the sum of the interior angles of a quadrilateral. Okay, is 360 degrees, just like squares and all. Alright, so the diagonals of what bisect each other and equal in length. Okay, so the diagonals of a in this case will be the rectangle. Okay, and the next one, diagonal of a because a square. Okay, square. Okay, then the next one, the diagonals of a what bisect each other. Okay, so in this case, it's a parallelogram. Okay, then the next one, the diagonals of a what bisect each other at 90 degrees, and then they bisect the interior angles. So in this case, it's a rhombus. Okay, and then finally, the diagonals of a what cut each other at 90 degrees, and one of them bisect the interior angles. So that is the kite. Okay, so in the kite, only one of the diagonals bisect the angles, right? Okay, where the line started from. Okay, just like this. Okay, so this is the diagonal that bisects the interior angles here and here. Okay. Alright, so the last few parts will be in a polygon, the interior angles plus the exterior angle is equals to 180 degrees. So what does it really mean is that if you have like a n-sided polygon, okay, be it regular or irregular, okay, the exterior angle is defined as this angle that is outside. So we call it as a line, like for example AB. This is AB produced, and then this is an exterior angle. Alright, and this is an interior angle. Okay, so the exterior angle plus the interior angle is a straight line here, which is 180 degrees. And then the sum of the interior angles of an n-sided polygon, this one we have been using this formula very often earlier, is n minus 2 times 180 degree. And this is the case for any polygon, be it regular side or non-regular side. If it's a regular side, that means you can find the specific angle for each side by just dividing by the number of sides. That's for the case for the regular n-sided polygon. Okay, then last but not least, the sum of any exterior angle of an n-sided polygon is simply 360 degrees. That applies for all kinds of polygon. Okay, and we know that once we actually look at this exterior angle here, okay, you shrink this entire polygon, you will end up to become a small dot. Okay, just like this. 1, 2, 3, 4, 5, 6, where it's 360 degrees. Alright, and that's about it.